2x over 1 plus x squared? Is that the paper homework? I think we had this one, right? Graph that. So all the fun stuff involved in this. Some of you already had reciprocation, but let's go through this. So by the way, the paper homework problems are harder than the exam problems. That's generally my philosophy. It's the hardest thing I give you is paper homework. So when you want to do any of these graphs, you want to find the minimum, the maximum, the points of inflection, the matching y coordinates, and then you want to draw the graph. And you will, with the minimum, the maximum, you can, increasing and decreasing, and concave up and concave down. So you can find a lot of stuff with just a couple of derivatives. Also, you should look at this and you should say, so since it's a rational expression, kind of numerator and denominator, what happens when x goes to infinity? So what's the limit of this as x goes to infinity? Huh? You should know this. Give it a shot. Good guess. So bottom power is bigger than the top power. So when x approaches infinity, this is going to approach 0. So it's going to have a horizontal asymptote of the x-axis. Okay? So let's take the first derivative. So the first derivative, we need the quotient rule. Bottom times derivative of top minus top times derivative of bottom over the bottom squared. Now normally, we won't bother to simplify if all I asked you for was the derivative. But since we're going to need to find zeros and we're going to need to find a second derivative, we want to simplify this. So this is 2 plus 2x squared minus 4x squared over 1 plus x squared squared, which is 2 minus 2x squared over 1 plus x squared squared. All right. That's the first derivative. So we'll come back to that in a minute. Now let's do the second derivative. We've got the bottom function times the derivative of the top minus the top function times the derivative of the bottom, which is 2 times 1 plus x squared, the 1 times 2x. So we need the chain rule for the bottom. Everybody knows there's a midterm a week from today? 8:45, same room as last time. Okay, don't forget. We only have one more topic to cover before the midterm. So I guess I'll squeeze a little more of this in today. All right, now we have to simplify that. That's a mess. But notice something. This is a 1 plus x squared squared, so it has a term of 1 plus x squared. This has a term of 1 plus x squared, and this has 4 of them. So I could take 1 plus x squared out of the numerator and the denominator. Then I'd be left with 1 plus x squared times minus 4x minus 2 minus 2x squared times 4x over 1 plus x squared cubed. Okay, so I took 1 plus x squared out of here, I took 1 plus x squared out of here, and I canceled them with a 1 plus x squared in the denominator. Okay? So I factored that out and I canceled it. That's why I only have cubed left. Got that? All right, so now let's simplify that. That's minus 4x cubed minus 8x plus 8x cubed over 1 plus x squared cubed, which is 4x cubed minus 4x. like something's a little wrong here. I guess that's okay. All right. So now we have to find some zeros. So the denominator is never 0. 1 plus x squared is always greater than or equal to 1. So we'll go back to the top, and to find where this is 0, just set the numerator equal to 0. So you get x equals plus or minus 1. Okay, and here you can take, again, the bottom is always positive. So we just have 4x times x squared minus 1 is 0, is 0, plus or minus 1. Now we can go to the number line. And test some values. I'm getting something funny going on here. These numbers are wrong. So I did some arithmetic error in here. So 1 plus x squared comes to minus 4x. It's 2 minus 2x squared. 2 plus x squared is 2x. 2 times 2 is 4x. 8x plus 8x cubed. Aha, found a mistake. I'm glad none of you spoke, because that would hurt. Okay, that makes more sense. So I take out 4x, I've got x squared minus 3. All right, so this is 12x. Speak up when you spot an error. So this has zeros at 0, and plus or minus the square root of 3. There we go. All right. So now, minimums and maximums. Pick a number less than -1, like -2, and plug it in here. The bottom's always positive, so you can just ignore it. At -2, the top is negative, so this function is going down. At 0, the top is positive, and at +2, it's negative. So we have a minimum here, and maximum there. So far, so good? Okay. Now let's check the second derivative for concavity. So the bottom again is always positive. Pick a number to the left of -3, the square root of -3, negative square root of 3, like -2, you get a negative times a positive. So this is negative, it's concave down here. Try a number like -1, and it's positive, so it's concave up. +1 is negative, so it's concave down. And at 2, everything's positive, so it's concave up. How are we doing so far? Okay, last thing is we're going to need some y-coordinates. And y-coordinates always go back to the original equation. So if you plug in -1, you get -2/2, which is -1. When you plug in +1, you get 2/2, which is 1. And negative square root of 3, you get -2 radical 3 over 4. So that's negative radical 3/2, which is about 0.8. When you plug in 0, you get 0. And the square root of 3, you get radical 3/2. Okay. Ready to graph it? So let's see. Goes to the origin. -1, -1. 1, 1. Square root of 3, square root of 3/2. negative square root of 3, comma, negative square root of 3 over 2. Function is decreasing until it gets to negative 1, and it starts at concave down, and it switches to concave up. And it's concave up till you get to the origin, then it switches to concave down again. It'll stay concave down till we get to here. And there you go. Isn't that a fun graph? Now, as I told you guys, you can use calculators. So you can get a picture of the graph first. But see all the various pieces that you can get out of it? Take a minute and absorb that. Yes, that's this point right there. Point of inflection. Good? The other graph is easier. Yes, is that a question? Just stretching and yawning. I do that to people. Feel free to ask questions. As I said, I wrote the exam. I didn't have anything that hard in the exam. Wouldn't do that to you guys. But you should be able to do something like that. The more important thing is you should understand a graph like this. So what is a graph like this doing? Forget the left part. You reach some peak, and then you come down, and then you just sort of flatten back out. Okay? You don't go up forever. You don't dive down. It flattens out. So there's cost functions that might look like that, or more likely profit functions. So you get to a maximum profit, and then maybe your costs start to get bigger and bigger. So at some point, you're not making any money. Your profit and your costs just sort of cancel each other out. So you would want to figure out, where is this spot? That's the best spot to be. Yes? But you have questions?
Can we do another one?
Can we do another one? Can I go over the other problem? Sure, well, let's review this again for a minute to make sure everybody understands. There's lots of algebra, okay? So first thing you do when you're doing a graph is you want to find the first derivative and the second derivative. So you get the first derivative, which you use the quotient rule. And then you can simplify the first derivative, and you can find zeros. So when you have a rational expression, when you find a fraction, you only have zeros when the numerator is 0, okay? Because when the denominator, you can't have a 0 in the denominator. And you would care about zeros, because that would be places where it would change from increasing to decreasing, but the denominator is never 0. X squared is always greater or equal to 0, and then you're adding 1. So we only care where the numerator is 0, and that turns out to be positive and negative 1. Now you go to the second derivative. This helps find your concavity. So you take the derivative again using the quotient rule, which is a bit messier. And you can simplify it. One of the tricks to simplifying these types that'll always work when you have a rational expression to a power in the denominator is you can factor out one of those, at least one of those terms. Yes?
What's even the second derivative?
I take the derivative of the derivative. That's the second derivative. Second derivative finds concavity. Okay? Concavity. Like if I had a hole in my tooth, that would be a concavity. All right, seeing if you're listening. Pull out a 1 plus x squared. Clearly that wasn't that funny. And now you get down to 1 plus x squared cubed. And simplify this again, and that's a 12, okay? And again, you can find the zeros by setting the numerator equal to 0, and you get 0 and plus or minus the square root of 3. Now you just have to test the values. So where first derivative is negative, function's going down, and where first derivative is positive, the function's going up. Where the second derivative is negative, it's concave down. And when the second derivative is negative, it's concave up. So now you've found increasing and decreasing. You figured out maximums and minimums. These are called points of inflection because the second derivative changes sign. You need the y-coordinates, and then you have to figure out what the graph looks like. So how do I know what the graph looks like? Well, I plot the points. I know there's a horizontal asymptote, so I know eventually I've got to get out to 0. And that this is a max. If that's a maximum and I have to end up back here, I have to come back down somehow. And if I don't switch concavity, I'll go down this way. So I have to go back to concave up so I can flatten out at the axis. Same on this side. Another question?
You plug to get the y-coordinates?
I always plug into the original equation to get the y-coordinates. Because this equation is y equals, right, or f of x equals. that's derivative. So for y values, I have to use y equals. That's why it's the original equation. So far, so good? I only made 2 people leave. I'm going to erase this in a second, so make sure you got it. Okay. Let's move on to the other one.
Is there any way we could do something that wasn't on the homework, because some of us had rectification already, and we handed it in?
Sure.
And everyone else is going to get 100, and we're not. I don't think that's
Well, that's true. Of course, I can factor that into your grade. So I wouldn't worry about the 100 part. I'd worry about the understanding part. But sure, I can do something similar.
Have sympathy
I have sympathy for everybody. Why do you guys worry a lot about these homeworks and these computer assignments, and you forget what a small fraction of your overall grade that is? Okay. Sorry? So, you know, 1 computer homework of a 0 is still not going to affect your grade very much. Good. Let's do something similar to the homework, but not the same. Let's say we had y equal x squared times 1 minus x squared. It's a couple of things you should say in your head. That's a 4th power. So that's going to look like a W probably. Maybe with something fun going on because there's a square in here and a square there. Now you could multiply that out with the derivative if you wanted. But it's in factored form, so you might want to leave it this way. But if you wanted to multiply it out, that's not too hard to do. The problem is if you do, when you take the derivative, you'll be left with a cubic. Cubics are not fun to factor unless you're a good factor. So let's just take the derivative. So we have the left function times the derivative of the right. Remember chain rule. Plus the right function times derivative of the left. Now how would we find when that's 0? Well, there's a couple of little tricks you can do for yourself. Notice, this contains a 1 minus x, 1 minus x squared. So you could pull 1 minus x out of this. And you're left with negative 1 times 2, so negative 2x squared. Plus 2x times 1 minus x. Bless you. This is 1 minus x times minus 2x squared plus 2x minus 2x squared. Or 1 minus x times minus 4x squared plus 2x. So that'll be easier to find zeros, and that won't be that hard to take the second derivative of. So again, see what I did? I took 1 minus x out of both terms. So here I'm only left with minus 1 times 2 times x squared. And here I'm left with one more 1 minus x and the 2x. And then I combine that and simplify it.
Where did the negative 2x come from?
Which negative 2x?
Negative 2x squared?
There's 2 of them. I don't know who asked me, so there's 2 of them. Here you have minus 2 times x squared, and here you have 2x times 1 minus x. So 2x times 1, 2x times negative x. So this is what I'm going to want to take the derivative of for the second derivative. So first function times the derivative of the second function, negative 8x plus 2, plus the second function times the derivative of the first function. That is 1 times negative 8x plus 8x squared plus 2 minus 2x plus 4x squared minus 2x. Oops, squared. Which is 12x squared minus 12x plus 2. Which does not have easy zeros. One of the problems I told you guys last class is either you get easy zeros for the first derivative but not the second, or the other way around. It's very hard to make everything come out easy. All right? The other way you could have done the second derivative is you could have FOILed this out and then taken the derivative. I think that's correct. And when you do the exams, make sure you're very careful that you get all these steps correct. Okay, I think we got it. Okay, so zeros. We could pull x out of here. In fact, we could take a negative 2x out. So we've got zeros at 1, 0, and a half. This is going to require the quadratic formula, but we could divide through by 2. So that's going to be and whip out the calculator so you can see what the graph looks like. We could simplify that radical if we wanted to. Square root of 12 is somewhere between 3 and 4. Okay? All right, let's do some sign tests. Pick a number less than 0. Like -1, I like that one. So let's see. That was my derivative. I get 2 times negative, so that's negative. So it's going down. Pick a number between 0 and a half, like a quarter. Positive. And let's see, that's a -1. Plus a half, so that's going to be still negative. So that means 0 is probably not a maximum or a minimum. It's just a flat spot. Pick a number between a half and 1, like 3/4. Positive, -9/16 plus 3/2. Positive, it's going up now. So that's a minimum. Pick a number bigger than 1, 2. Negative times negative is positive. So again, flat spot. Why is that happening, by the way? Because of the squaring. Okay? So squaring is telling me that something funny is going to happen. All right, this I could simplify, but I don't really have to. I've got 6 minus the square root of 12 over 12, 6 plus the square root of 12 over 12. You want to get a feeling for how big those are. Square root of 12 is about 3.5. So this will be a small fraction, so 0 will work. This is between. This is 6 minus this number and 6 plus this number over 12, so the middle number. So half will be a good test value. And then a number bigger than this, we could use any number we want, like 10. So you go to the second derivative. You plug in 0, you get plus, so it's concave up. You plug in a half, and it's negative, so it's concave down. And then concave up again. Lost the numbers. All right, y coordinates. Well, x equals 0, y equals 0, and x equals 1, y equals 0. And x equals a half, you get a quarter times a quarter, which is a 16th. I'm not going to try to find the y coordinates for the points of inflection. It's too hard. Okay? I mean, you can do it, but it's annoying. So what do you know what's happening? Well, we have a minimum here at 0, and I'm sorry, at a half. Is that right? Yeah. Graph makes no sense. Because it's 0, 0. It's a half of 16. It should be a negative number. Did I do that correctly? I need a calculation error. See if I can figure it out. For my notes. Everybody check your phones for 30 seconds. That's positive. That's what you're wrong. Done. Okay. All right, let's do that. So it's a minimum, a maximum, and a minimum. As I said, that's why I use calculators. So that means the graph looks something like that. Okay? And these are your points of inflection. So this is 6 plus the square root of 12 over 12, and then 6 minus the square root of 12 over 12. He said you should feel free to use your calculator to have a feeling for what the graph looks like, help you find points, all that stuff. You guys are a little numb from these? Boy, calculus got hard in a hurry, didn't it? This is the worst part. As I said, the graphs won't be quite as bad on the midterm. I don't want to free call you out. You don't look happy. Nobody has any questions. You're just sitting silently. Which means if you have questions later, you should have asked them now. Okay? So it's very important when you test. Don't always trust doing it in your head. Make sure that you test it. That you get the signs correct. Yes?
You should go to the Math Learning Center with paper homework, or they'll want to help us.
You have to, that's up to them. Yeah. That wasn't really a relevant question, but it's a good question.
Just like asking.
It's okay, yeah. I mean, they're supposed to help you, okay?
Yeah, because I was there before I handed out my last paper homework, and then they helped me.
Okay.
Suddenly, if someone is really concerned about getting the whole number at paper homework, they can go to the Math Learning Center before they hand out their.
I think homework is a learning exercise. It's not about the grade, it's about learning from the homework. Okay, so feel free to go to the Learning Center and have them help you. I wouldn't feel tight about that at all. I don't have any issues with that. Other questions? Now? You guys are all packing up, so you're assuming I'm done. Okay. I can be done. So we're doing something new on Wednesday. So get this down. See you Wednesday.